Here's the next question, number 17. In the portion of a circuit shown, if the heat generated in 5 ohm resistor is 10 calories per second, then heat generated at the 4 ohm resistor in calorie per second is dash. Now this is not a multiple choice question, so we will have to work it out. Now in the figure shown, we see that the 5 ohm resistor is in parallel with the 4 ohm and 6 ohm resistors in series. So please keep that in mind. Also, the units given here, calorie per second. Now you should know that calorie per second is energy per time. And energy per time is the ratio of power, which means that calorie per second is also watt. Now the questions might seem a little confusing at times, but you will have to go back to the very basics. So don't be confused with units as such. You will have to come back and try to see how it relates to the basics of what we know. Okay, so the question says that the power at 5 ohm is 10 watts. 10 calories per second is 10 watts. So let me just write that. Power at 5 ohm resistor is 10 watts. Okay, so now let me write down the different formulas for power as we know. We know that power is energy divided by time. We also know that it is voltage times current, V square by R, and also RI square. So these are the different relations. Now it helps for you to remember all of this so that you can use the best formula for the question given. Okay, so let's check and see. We have 10 watts here and we have the resistance. So let's find out what is the voltage across this resistance here. Okay, so the most probable ratio is this. So power is equal to V square by R, and we know that P is 10, so 10 equals V square by the resistor is 5. That implies that V square is 50 and V is root 50. Now note that this voltage is across the resistor 5 ohm resistor. Let's keep this in mind now. Okay, so we are asked to find out the power that is dissipated in this resistor here, 4 ohm resistor. So let's look at the circuit. 5 ohm is in parallel with these two, which means that the voltage across this branch is the same as the voltage across this. It is the same. But in this branch we have two resistors, 4 ohm and 6 ohm, which means that the voltage is divided here. We have one voltage here across this resistor and we have another voltage here across this resistor. We are supposed to find out what V1 is in order to find what P is. So let me write this here. Okay, so we need V1. We can find V1 by using voltage divider formula. Now the voltage divider formula says that the voltage across a certain resistor, let's say A, can be found by multiplying the total voltage to the ratio of RA by RT. Okay, so if I apply this to the circuit here, we can find what V1 is. VT is what we have found here, root 50 times RA is 4 divided by 10. Okay, so let me use the same value here and apply it directly to the power, since we need to find the power. So power across the 4 ohm resistor can be written as root 50 times 4 by 10 whole square divided by 4. So this is the basic relation. Okay, so we can take 1 by 4 outside and try to solve this, square it. You will obtain 2 watts. Now I will leave the simplification to you. Just know that the final answer is 2 watts here. So the answer is 2. So there's no need of conversion because we know that calories per second itself is watts. So the answer is 2. I hope this has helped.